The scientific method. Let's begin by discussing what science is first. Science is simply a logical way of thinking about the world around us. Scientists use observations about the world around them to make inferences. Observations are made using your 5 senses, and an inference is a logical guess or a prediction that you make based upon your observations. Science is a subject that is always growing and changing, and this happens because of the new information that is constantly being received. Science is one of the unique disciplines where what we know today could be completely different tomorrow. And this is really impacted by our developing technology. So what is the scientific method? The scientific method is a term that we use to describe the way scientists gather information and use that information to help solve a problem. We always begin by making an observation. Observations lead us to ask questions. When we have those questions, then we research them, make a prediction, conduct an experiment. From our experiment, we analyze our data and we draw conclusions. All of your experiments should be able to be replicated and get the same results as you did. After our experimentation, our findings should be reported and shared, and they should be shared for peer review so that we can make sure that other people get the same results as we do. Step 1 of the scientific method is make an observation or state the problem. Then you have to gather some research, and then you need to make a hypothesis. You may have learned that a hypothesis is an educated guess. We're going to take that a little bit further, and we're going to say that a hypothesis is a testable explanation to an observation. We then must test our hypothesis by doing an experiment. Experiments could also be done by making observations. When we talk about things like ecology, we can't go out and we can't change things in the environment because we could damage the environment. As we are doing our experiment, we collect data and analyze that data. We use that to form a conclusion. If the data does not support our hypothesis, it doesn't mean that you made a mistake. It simply means that the hypothesis you had may be incorrect. Could there have been a mistake in the experimental process that you did? Yes. If our hypothesis is not supported, what we do is we go back and we begin the process all over again. Remember, your findings should be able to be replicated, and once we have conducted our experiments, we need to be able to share our information with others and have them be able to peer review it. So let's talk a little bit about observations. We use the scientific method every day in our life. Examples would be this. We make an observation that we get home from a friend's house and we put the lock in the key and we can't open the door. Our observation is the key is not working in the lock. So now this begins into our steps of the scientific method. We stated the problem. Why can't I get the door open? We're going to gather information. My key's not turning. Hypothesis, I used the wrong key. How could we test this? Use a different key. We're going to collect the data by looking at Does the new key that we selected turn in the lock? Conclusion. Since the other key opens the door, I must have used the wrong key the first time. Our hypothesis was supported, so we don't have to go back and conduct the experiment again. So how is a hypothesis formed? Remember, a hypothesis is a testable explanation to a question or a problem. They are often in what we call if-then statements. If I test to see why the key isn't working, then it's because I used the wrong key. They are often logical. They use reasoning. There are two types of reasonings that we have. We can have inductive reasoning, which looks for patterns or rules in the real world, or deductive reasoning, which compares new things to the rules of the natural world. An example of inductive reasoning is this animal is a bird and it has feathers. That animal is a bird, it has feathers. The rule or pattern is all birds have feathers. This is a inductive reasoning. We're developing a rule of nature after many observations. Deductive reasoning is like if all birds have feathers, then when we discover something new and it has feathers, it must be a bird. If electricity is needed to turn on lights and they are not on, then there's no electricity going to the lights. If a light needs a filament to turn on and it's not working, then the filament is burnt out. That is deductive reasoning. So let's talk about a controlled experiment. So we want to test our experiments, or to test our hypothesis with a controlled experiment. So a controlled experiment is one that changes only one variable at a time. We do this because if we change too many variables in an experiment, then it can be hard for us to understand why we got the results. So when we do an experiment, we only change one thing or variable at a time. Examples would be, two groups of people get a pill. One gets a pill that contains the new medicine to be tested. The other group, the control group, gets the pill that does not contain the drug. We have only changed one thing. One group, the experimental group, gets the pill. The other group gets a pill, but it doesn't have the medicine. They still will take the same amounts, the same size, it will be the same color, but we have only changed one thing. Another example is that we have two groups of students that are taught algebra. One uses a new method, that's the experimental group. The other group, the control group, uses the old way. Again, we are only changing one thing. So in that experiment, it would be the same teacher teaching both groups, using a different method with one group than the other. So parts of the controlled experiment are the controls. These are all of the things that you're keeping the same. The thing that you are changing is referred to as the independent variable, and the results that you get from changing the independent variable are the dependent variable. In summary, the scientific method is a great way to use observations to make predictions. Our predictions lead us to make a testable explanation, which is a hypothesis. So let's talk a little bit about the data. So data can be organized into charts, graphs, or tables. We then use these to analyze our results and put them in a easier readable format. There are two types of data. Qualitative data, which discusses the qualities. They are describing, they are words. Quantitative is a number. It is things like measurements. Quantity, quantitative, quantitative is always a number. When we graph things, the independent variable goes on the x-axis. The dependent variable goes on the y-axis. So how do scientists form a conclusion? A conclusion will either support or reject the hypothesis. We come up with this by analyzing our data. Our conclusion is not always proof that the hypothesis is true or false. Scientists do not use it to prove that something's true. We can disprove it by doing an experiment, but it often takes many tries to prove whether something is correct or not. By repeating the experiment, we become more and more confident in our results. Once we're more confident in our results, we can share our data and we can have our peers or the rest of the scientific community review our things to help further our knowledge on that subject. So the biggest things to remember are qualitative and quantitative are the two types of data. And we use that data to make charts, tables, and graphs. And our conclusions are based upon analyzing